Good morning, majors. So today we're going to start polygons. This is Unit 8, Day 1. And the things that we need to know about a polygon, the properties of a polygon, is it is a closed figure and it has to have 3 or more straight lines. Polygons cannot have any curved sides. So right away I know this is not a polygon. Right here, this one is also not a polygon. This one is not a polygon, no curved sides. It has to be closed, which means that it has to connect. So this one does not connect. This one is not a polygon. You're going to say no. It is a polygon is equilateral if all the sides are congruent, equal angular if all the angles are congruent, and it is regular, this is a new word for this chapter, if all the sides are congruent and all the angles are congruent. So this one is a square and it is a polygon. It's closed and there's no curves, and it looks like all my sides are equal, so it is equilateral, and it looks like all my angles are 90 degrees, so it's equal angular, so it is also regular. Okay, I want you guys to go through and try this out. So this one is a 1, 2, 3, 4, 5 hexagon. All of my angles are equal. All of my sides appear to be equal. So you're going to say, yes, it's a polygon, and it is also regular. This one, this side doesn't really look like it's equal to this side, so it's not regular, but it looks like all of my angles are at 90-degree angles. So it's a polygon, it's closed, and it doesn't have any curves, but it is only equilateral. So I'll put it on top, equilateral. Okay, so try the rest out. The sides, I want you guys to try to look up online. If it has one side that is called a line, right? It's just a straight line, it's a line, and that's not a polygon. It has to have at least 3. We know that 2 lines make an angle. And that is also not a polygon. Three lines we know is a triangle. Four is a quadrilateral. That's this chapter. My handwriting on this. So you guys can look this up. 5 is a pentagon. 9 is a nonagon. This is very important. We use nonagon a lot. And anything over 11, we say it is that number gone. So if it was 12, that's a 12-gon. 18, that's an 18-gon. So I want you guys to figure out the rest of these. Oh, 12 is right here. 12 is a dodecagon. Gone. Alright, what is the sum of the interior angles of a triangle? We've already gone over that. We know that the interior angles of a triangle always add up. Sum means add up to equal 180. However, we have a formula to find the interior angles of any polygon. And the way we've derived it is by finding out how many triangles are in that polygon. So in this polygon, this is a pentagon. My n is a number of sides. So this one is going to be the number of sides. And in this case, I have 1, 2, 3, 4, 5 sides. And how many triangles do I have? I have 1, 2, 3 triangles. It's always going to be n minus 2. And then the sum of the interior angles is 180 plus 180 plus 180, right? Each of them are 180. And that equals 540. If you add them up. Alright, let's try this one. I have 1, 2, 3, 4, 5, 6 sides, so n is 6. The number of triangles I can make is n minus 2, and I'll show you why. So I have 1, 2, 3, 4 triangles, which is 6 minus 2. And then the sum of the interior angles is 180 plus 180 plus 180 plus 180, or 180 times 4, which is 1260. We can always drive it that way. So try number 3. We also have, so I want you guys to try the rest actually, 4, 5, and 6. We have an interior angle formula, and that is n minus 2, right? The number of sides minus 2, and then we multiply that by 180 to find each interior angle. Each means 1. So every single time they ask us for each, I want you to put 1 on top of it. 1 interior angle is going to be n minus 2, all of them, times 180, right? And then divide it by the number of sides, so n, and that'll give you 1 interior angle. Find the measure of each interior angle of a regular polygon. This is why we need those formulas, because we can't do that by hand. That would take a lot of time. If we wanted to draw a polygon and make our triangles, that would take a lot of time. So we're going to use the formula. But this one says each interior angle. So we're looking at 1 interior angle, and that's this formula. So I'm going to, my n is 40, so my n is going to be 40. I'm just going to plug it into the formula. Make sure to use your parentheses. So I have 40, right, minus 2 times 180 divided by 40. So plug this into your calculator and see what you get. The measure of each interior angle of a regular polygon is 150 degrees. So they're giving you the each interior angle, and then they want you to tell them how many sides. So they're asking you for n. What is n? So in this case, we have 150 equals n minus 2 times 180 divided by n. We're always going to cross multiply in this case. Put a 1 under here. And cross multiply. So 50 times n, 150 times n is 150n. N minus 2 times 180. You're always going to have to distribute that 180. So that's 150n equals 180n minus 180 times 2 is 360. And then we're trying to solve for n. So you have to move this 180 over. Oh, I'm sorry. Move it over. In this case, it's gonna give you negative 30 and equals negative 360. And when you divide each side by negative 30, we're gonna get n equals 360 divided by 30 is 12. So that is going to be a dodecagon. So any 12-sided figure is dodecagon. I think that's how you spell it. All right. So go ahead and flip your paper over. Interior angles. So now we're going to look at an exterior angle. Interior angles are in the inside of your polygon, and an exterior angle is on the outside of your polygon. What is the sum of each exterior angle and its neighboring interior angle and its neighboring exterior angle in y? So remember that we have this interior angle right here, and then when we form this straight line with this exterior angle, what they want to know what this is going to be. But this is a straight line, so we know that it equals 180, and explain that because it's a straight line. What is the sum of the exterior angles of this polygon? So if we add up the exterior angles of a polygon, it is always going to equal 360 degrees. It doesn't matter what kind of polygon it is. Okay, draw the exterior angles on the octagon below and find the sum of the exterior angles. So it doesn't matter what kind of polygon it is. We know that they're going to equal 180. The exterior angles are formed by just extending the side. So extend the side, keep going. Could have gone the other way. I'm going clockwise. going. And these are the exterior angles right here. And they're always going to add up to equal 360. Doesn't matter what kind of triangle it is or what kind of polygon it is. So my formula is they always add up to be 360. It doesn't matter the number of sides we have, but if we're trying to find each exterior angle, we're just going to divide that 360 divided by the number of sides, which is n. All right, guys. So I'm going to help you guys with one more, and then I want you guys to try out some examples. So what is the measure of each, which means one exterior angle of an 11gon? So I know that the sum is 360. Divide that by 11. Find out what you get. Based on the relationship between the interior and exterior angles, what is the measure of each interior angle of 11gon? So whatever this is, we can subtract that from 180, or we can just plug it into our formula. Each interior is 180 times n minus 2 divided by n. All right, guys. So I want you guys to try the rest, and we'll go over it in class tomorrow. Have a great night.